welcome to Maths Chat. Today I'm going to show you how to follow a process of something called completing the square. Now, when I teach this in the classroom, often students are left mind blown because of how long and tedious the process can be, and often it takes up most of the whiteboards in the room. So I'm just giving you a warning, it's actually not that hard, it's just quite a process. So get your pens and paper out so that you can follow along, and let's have a look. The first step is to take the first term, divide it by 2, square that number, and add it onto the end. It's as if I'm taking this part, I'm adding onto it. X squared plus 6x. Then I take the 6, divide it by 2, add it on, and square it. Now, what I've done there is I've actually created a perfect square. You may recall that the perfect square rule is a plus b squared, and that's equal to a squared plus 2ab plus b squared. And I've set that up by dividing that by 2 and squaring it. I've actually set up a perfect square. I can't just go add on things in an equation and then it not be balanced. So at this point, this is where because I added 6 over 2 squared, I've got to then, after this point, subtract it. 6 over 2 squared. And then obviously I've got the positive 7 still on the end. So I put that there. At this point, I can simplify what's in my brackets. So 6 divided by 2, sometimes you won't be able to simplify that, but we can. So let's change that up. At this point, because I've set this up like so, and I know that the perfect square exists, I'm going to factorize just that part, using the fact that 3 is b and a is x. I'm going to rewrite this as x plus 3 squared. And that has come from this rule up here, which I've gone over in previous videos. So this is brand new to you. I recommend going back over the perfect square video of factorization and see the connection between a plus b squared and a squared plus 2ab plus b squared. Alright, now let's put these other ones on the end. So negative 9 plus 7. The negative 9 plus 7 part, because they're both numbers, I can just simplify them further. X plus 3 squared minus 9 plus 7 becomes minus 2, and we're not finished just yet. Let's quickly go over what we've done so far. We have halved the second one, so we've added on b over 2 squared, remembering that that's a, b, c, and subtracted it. We have used the perfect square rule. Perfect square. Now at this point, this is what we call a difference of 2 squares. So the difference of 2 square rule is when I've got a squared minus b squared, that is equal to a minus b, a plus b. Going back to this one, my a is x plus 3, and my b is a square root of 2. So I rewrite that, x plus 3 minus root 2. I rewrite that now factorized. X plus 3, remember this one, it just stays the same. And then plus root 2. So the only thing that I've changed, or where the difference in the negative and positive is right here. So you see that's a negative, and that's a positive. Where x plus 3 is my a, and b is root 2. Now I'll just put that in and say difference of 2 squares. Now I'm going to show you another example. Remember, the first step is to take whatever b is, divide it by 2, and square it. So b in this case is 9. That stays the same. This stays the same. It's like I've broken it up there. Then I add on 9/2 squared, and I've created perfect square scenario. Then, of course, I need to subtract now 9/2 squared, and then I've got the minus 5/2 on the end. Don't forget about that one. And now 9/2 doesn't simplify anymore, so I'm just going to leave it as a fraction for the rest of our example. Now this, reminder, this creates a perfect square where this is A and 9/2 is B. And the perfect square rule is that A minus B, this is the other part. Before, in the previous example, we looked at the positive, and now this one in here is negative. A squared minus 2AB plus B squared. Okay, so now we've got a negative here, which means we're going to be working with this one here. Because A is my x, I just have x minus 9/2 squared. And then that, I've carried out the perfect square rule. Now over here, minus, now I'm going to simplify what's in my brackets. So remember, this is actually applies to both of those. So it's 81/4, because 9 to the power of 2 is 81, and 2 to the power of 2 is 4. And I've got minus 5/2 over here. Alright, now the next step, you may recall, is we add these two together or combine them. In this particular case, you'll see that they've got different denominators, which means I can't add just yet. So to add or subtract fractions, they have to have the same denominator. To do that, I can make the denominators the same. And the easiest way to do that is to make this 2 into a 4. I'm going to multiply by 2, multiply by 2, and that creates 81/4 minus 10/4. And now I combine these two, which becomes negative 91/4. Alright, so a quick recap. What we've done is we've created the perfect square by adding B/2 squared. Then we've combined the second lot of numbers, which in the previous one it was quite easy because they were both just whole numbers. Now they're fractions, so we had to make the denominators the same. Then we combine those ones, which has become 91/4. At this point, this is where the difference of 2 square rule comes in. So remember, we've got A minus B, A plus B is equal to A squared minus B squared. A is equal to x minus 9/2, and B is equal to the square root of 91/4, which simplifies to the square root of 91/2, because I'm finding the square root of each of them. Alright, so now when we put it together, I've got x minus 9/2 minus square root of 91/2, x minus 9/2 plus the square root of 91/2. Now, you could leave this as your answer, but a nicer way to write it would be to put all of that on the fraction together. Over 2, x minus 9 plus root 91/2. And you can just leave your answer like that. Please hit like and subscribe to the channel so that you can be updated with any tutorials that you might need with your maths in the future. See ya!